Hi all, welcome to the 8085 MICROPROCESSOR ARCHITECTURE lecturer. So this is Chandra Kumar, Assistant Professor, Tamil College of Engineering and Technology, Tolurpatti, Tottiyam. So today we want to see about the 8085 microprocessor and architecture in a brief manner. So what is a microprocessor? So first of all, it is a semiconductor component, is it right? So that incorporates the functions of a central processing unit, which is called a CPU, on a single integrated circuit. So IC. So combination of a CPU on in that CPU we can integrate it with a single IC. So that is the central processing unit built on a single IC is a combined one is called a microprocessor. So microprocessor and microcontroller, they have a various different unique features. So we want to see discussed in microprocessor only. So it is a multi-purpose and a programmable one and have a clock driven. So it is a very important thing. So it is a multi-purpose and it's have a program. Whatever the program we will give, and it is a clock driven. So it is a register based electronic device. So what is the register? We want to see one by one in upcoming slides. So that reads a binary instruction from the storage devices called memory. So what is that memory? Likewise, nowadays we are using the more than 3 GB, 4 GB, 5 GB likewise. So in that memory we are using that bits, okay, not a byte, it's a bit. So the accept of binary data process and the data according to the instruction, it can proceed the output. So whatever may be the input we can given as a binary data. So whatever may be the output we needed. So we need to conclude. So it is an important thing. So what is the architecture of 8085? So what is the outcome in the 8085? They have three main sections. So one is ALU, arithmetic and logic unit, already known, on timing and control unit, and set of registers. So registers is known as some of the data storage devices. So okay, this is the main architecture of 8085. So in that architecture, we are having the whole registers, accumulators, temporary register, flag, ALU, control unit and timing unit. So it is the diagram as shown in the slides. So it is a real-time architecture of 8085. So in that 8085, they have important things already we seen that they have an internal data bus and the ALU timing control unit. So all are having the important and unique features. So we are going with that first initial one, ALU. So arithmetic and logic unit. So it is one of the important thing. Then as well as the accumulator temporary register flags. So what is accumulator temporary register flag? We want to see one by one. So after that they have a very important another important thing, timing and control unit. So whatever may be the inputs you can given to the microprocessor. So in that we are using the timing and control unit to control whatever may be the output we needed. So they have interrupt control. So whatever may be the input we needed, so as well as we can give this as output. Then serial input and output ports, so registers. So these are the various type of registers: W, Z, B, C, D, E, H, L. Then ALU. So already we know that ALU, arithmetic and logic unit, what are the input so binary numbers we can given, so it can be given as output. So this is the main architecture of 8085. So what is by ALU? So arithmetic, addition, subtraction, logical. So AND gate, OR gate, NAND gate, NOR gate, etc. The various type of gate they can be given as an input. It can continuously working and given as the output. So this is the ALU as located in the center of that architecture. Then second one, timing and control unit. Already seen the timing and control unit. They have a clock output ready, read, write, ALE, serial input and a serial output S0 and S1, input output mode, hold, reset. So whatever may be the contents we need to give as an input, we can be given that the controls are to the entire operation of the microprocessor. Then third one, registers. So we already know that they have a storage one, not in a GB level. So it is in a bit levels. So one 8-bit register and 6 they have a purpose register. So one is to be considered as a accumulator. So A it should be represented as accumulator, and 6 8-bit register is a general purpose register, already we seen in that accumulator diagram. So W, Z, B, C, H, E, D, E, H, L, so etc. So these are the contents we are giving that they have a 8-bit. So it having a maximum capacity of 8-bit. So one 16-bit register is contained in that diagram. So it's a stack pointer. It is a 16-bit register. Two 8-bit to be considered to giving that 16-bit, and one another 16-bit will be considered as a program counter (PC). So it is also available in the architecture diagram. So SP and PC. Okay, they have another one, instruction register, temporary register and flag register. So all are available in that diagrams. So what is the purpose of register? You are giving that the numbers. So it's a binary number 0 and 1s. Whatever may be the function you need, it should be converted from 0 to 1 to the final output. So it's a usage of register. So first one, what is the accumulator? So already we seen that it is a 8-bit register. So it holds one of the data processed by the CPU. So what is CPU? Arithmetic and logic unit, giving that one of the main important thing is the CPU. So it holds the data, whatever may be the data we can give and it can be processed. So another, it is connected, accumulator is connected in the 8-bit data bus. So already we seen in the diagram 8-bit internal data bus, is it right? So 8-bit internal data bus, the accumulator will give us a signal and receives a signal from the 8-bit data bus wherever the interrupt control and the serial input and output controls, whatever may be the inputs given, the accumulator can receive, as well as a temporary register also can receive. So regarding that in the application, so it can works. So it has a bidirectional array. Already we know that they have two directions. So from accumulator to the internal data bus and to the internal data bus to the accumulator. So it is a bidirectional one, and it is used to sense or receives data. The next one, temporary register. So it receives the data processed by the ALU from external memory. Is it right? So it receives the data processed from the ALU from the external memory. The other output for the temporary register. The other output for the temporary register, it can be concluded. So whatever may be the other outputs, so you are given that another instruction to that, so it can be temporary register can store the instruction and it can execute it. So copied elements, so whatever may be the accumulator thing, it can be saved, the copied elements can be recreated to the temporary register. So general purpose registers, we already seen that they have 6 general purpose registers. So 8085 they are having a 6 and 8-bit general purpose register. So already we can see that a 6 general purpose register, it having the 8-bit contents. So 8-bit storage. So the names are B, C, D, E and H, L. So we need to give that a 16-bit register. The 16-bit register cannot be created. So it's a combination of two 8-bit registers. So it is that they have a 16-bit register is known as a register pair, that the combination of two 8-bit registers it should be considered as a 16-bit registers. The programmer cannot form the register pair. So based upon the working, based upon the application, it can conclude it for the 16-bit register. The programmer, as a programmer, I cannot give this is a 16-bit register. The two 16-bit register are needed. Likewise, we don't need to implement that. So it can't accept. So based upon the application, it can be registered. It can be paired to the 8 and 8 bits to give us a 16-bit. So HL pair act as a memory pointer for the 16-bit register address. So HL pair, it is available in our architecture diagram. So once again, we will see. So another one, stack pointer. So it is also a 16-bit memory pointer. It maintains a last entered data to the stack. So what is on the stack? So stack is one of the storage area for the RAM, because the RAM is a purpose to speed up the process. So microprocessor, we are using that speed. They have a lowest memory and lowest RAM. So in that, the last storage memory, whatever may be the memories, we can copy it in your laptop or as well as some of the programs, it can be stored until they have another copied one. Likewise, the stack portion of the RAM, it maintains a last entered data. It is a stack pointer. So next one, program counter. The 16-bit special purpose register is considered as a program counter. Already we saw that 16-bit is not a created, it's a two 8-bit combination which gives us a 16-bit registers. It holds the memory address for the next instruction is executed. So whatever may be the instruction, we will give the sequence manner. So it can be holds and it can execute to the next one. Next instruction can be executed. So instruction register and decoder. So opcode. So output code will be instruction and registered and decoded will be executed. It follows the entire instruction and directs the timing control unit accordingly. So whatever may be the instructions we can given, it follows to the entire instruction. So 1, 2, 3 and sequence orders with respect to the timing control, it can be mapped and to the register, and whatever may be the output they can be given, we can get as a final output. So flag register, so already we seen about the various type of registers with the 8 bits. So flag register would be consist of carry flag, party flag, auxiliary carry flag, zero flag and sign flag. So at the carry flag, likewise we are using that arithmetic and logic unit. So like carry flags and borrows one of the numbers to the for the arithmetic operation. Likewise, we can carry. So party flag is it a set? It results in an even number. Otherwise, it can be made as zero. So the output given as a even number. It can be works. Otherwise, it can be zero. Auxiliary carry flag. So binary coded decimal operations only it can be carried out. Then zero flag. So in that zero flag, it sets as the results. It becomes zero. Then sign flag. It should be denoted as S. It's a sets of the results become negative and positive if the sets to be zero. So whatever may be the values we need to give and whatever may be the input and as well as output. So likewise the flag registers we want to set. So interrupt control we already seen in that arithmetic diagram. So interrupt control is a very important one. It is an input for the execution. So main program to answer the request from the input device, the interrupt control. For example, the best example we are using the laptop or and as well as system. So in the laptop and system we are inserting the pen drive. So at that time the interrupt control accepts and they have some dialog box will be open. Likewise, the interrupt control is a very important thing. Otherwise, if the pen drive is inserted means we can't know when the pen drive is inserted and what are the data it can be copied. So likewise, it is necessary input execution of the main program to answer a request from the input device. So interrupt control indicates the data is ready for the input. So the data is ready for the input. If data input takes place automatically, the main program returns to the first step. So whatever may be the data takes place, the automatical step procedure, it returns to the main program and it can works. So example, reading of the book when phone interrupts. So if the phone interrupts at the time of a phone coming at the time of reading the books, so it can one of the interrupt one. So at that time you are starting from the starting point of the book you can read. Is it right? So likewise, the interrupt control can works. Then serial input and output ports. So it's a very important thing. Serial input and output ports. So in that serial input and output ports, the input and output devices works the serial data rather than parallel. So it is working under the serial condition, not in a parallel one. So these are the contents you can given in the architecture. So this is the architecture. So we can clearly know that the architecture one. And after that we have a pin diagram, 8085 pin diagram. So it is a transistor pin. So you can be used as a totally 40 pins. So input, output, reset, trap. So they have a various one. So we will see in the next video the pin diagram of 8085 microprocessor. Thank you.